Let's do an example of Gaussian elimination and back substitution. Here we have three equations and we have three variables. First, we write the augmented matrix. So 1, 2, -1, those are my coefficients of x. Okay, our goal is to write this in row echelon form. In other words, we want to have this to where we have ones down the principal diagonal and then zeros below it, and then these others are going to be just whatever they turn out to be. Once we get it to look like this, we'll be able to solve it with back substitution. So that's what we want to get. Now, the way that you do this is in each column we get the ones first and then the zeros. If you do that, the steps you do later will not undo the steps that you do at the beginning. So the first thing that we want to do is we want to get this first entry to be a 1, and it already is, so we're fortunate with that. Then next we want these guys to be zeros. Now, you can do this in two separate steps, but since they're going to be done independently, the way I get the 0 in the second row is not going to affect anything in the third row. I can actually do these in one step if I want, and that's what I will usually do just to save space. So I'm going to rewrite my first row as it is. It's going to stay. And then to get a 0 in the second row, take the opposite of that number that's there, so -2, multiply by the row that has a 1 in it, which is row 1. Add it to the row you're working with, which is row 2, and then put it back into the row that you're working with. Okay, so I'm going to put some scratch work down here below. So when I do -2, row 1. Okay, so take your first row, multiply it by -2. What will that give me? -2, +4, +2, and -4. That's -2, row 1. And now let's put row 2. 2, -1, 1, and 4. And now we're going to add them. So that gives me 0, 3, 3, and 0. Okay, this goes back into row 2. 0, 3, 3, and 0. Now we need to get a 0 in the third row in that first position, so take the opposite of that number, so that'll be +1. Multiply it by the row with the 1 in it, which will be row 1. Notice we're going all the way back to row 1. Add it to the row you're working with, which is row 3, and then back into row 3. So when we do row 1, okay, well that we don't have to do any multiplying. We can just write it down as is. So 1, -2, -1. And then 2. And now we write down row 3 and we just add these together. So -1, 1, -2, -4, that's my row 3. And so then I add them. I'm going to get 0, -1, -3, and -2. Again, you want to don't do your scratch work in between your matrices. Do it off to the side. I'm putting it below here so that you could see it. If I was actually doing it, I'd probably put it on a separate sheet of paper. And you'll probably find as you get good at this, you need a little less scratch work. So now our goal is to get a 1 in this position. To do that, to get a 1, you multiply that row by the reciprocal of the number that is there. So we're going to multiply that row by 1/3. So multiply by row 2 by 1/3 and put it back into row 2. So my first row remains unchanged. Second row gets multiplied by 1/3, so 3 times 1/3 is 1, 3 times 1/3 is 1, 0 times 1/3 is still 0. Third row is unchanged. Okay, now we want to get a 0 below that 1 in the second row. In other words, we want this to be a 0. In each column, we're going to get the 1 and then get the zeros. Don't start on the second column until you're finished with the first column. Don't start on the third until you are finished with the second. So we want that to be a 0. Okay, how do we turn a number into a 0? We take its opposite, which will be positive 1, multiply by the row that has the 1 in it that we created. So that is row 2, right? And then we add it to the row we're working with, which is row 3, and then back into row 3. So my first row remains unchanged. My second row remains unchanged. And now I just need to take row 2 plus row 3. So row 2, and this you probably don't even need to write anything since you're just adding the 2 rows. 0, 1, 1, 0. That's row 2. Row 3 is 0, negative 1, negative 3, negative 2. And then when we add them, we're going to get 0, 0, negative 2, and negative 2. And that's what we're going to have here. 0, 0, negative 2, and negative 2. So now our goal is to get this to be a 1. Okay, how do we get a number to be a 1? We multiply that row by the reciprocal of that number. So now I'm going to simply multiply by the third row by the reciprocal of the negative 2, which is negative 1/2. Row 3, we're going to put it into row 3. So this is going to give me 0, 0, 1, 1. My other 2 rows stay there. So now we have it in what we call row echelon form. And that's what we want. We still have to solve our system. So what we're going to do is we're going to write down the equations that come from this. First of all, what letters are we using? We're using x, y, and z. If you need to, you can write those above the top. We'll probably all be doing that when we get to the real complicated ones. So we write x, y, and z there. Look at the bottom row first. So that gives me a z of 1. And now we want to look at row 2. What does row 2 say? Row 2 says that 1y plus 1z equals 0. And so we substitute z equals 1 into here, so and then we get y plus 1 equals 0, and therefore y is negative 1. And then we go to row 1, which tells us that x minus 2y minus 1z equals 2. And so now we're going to substitute in z equals 1 and y equals negative 1. And so then we get x minus 2 times negative 1 plus, minus 1 times 1 equals 2. X plus 2 minus 1 And so my x then is 1. And so now we want to write our answer. And so you could write it as x, y, z as an order triple. So that gives me 1, -1, and 1. And this is fine. Or alternatively, you could write x equals 1, y equals -1, z equals 1. That's okay too. Whichever way you want to write it is fine. Make sure that you remember to check in the original system. I'm not going to do that here, but just plug them back in with these simple numbers. You can probably do it without even writing anything down into original system. And that way you'll know for sure that you've done it correctly. Let's do another example. Let's solve this system using Gaussian elimination and back substitution. So we first write the system. First, let me make sure all my symbols came through properly in this program. Okay, I think they all look okay now. That last equation, a minus 2b plus 3c is equal to -4. So we write our augmented system, our augmented matrix. So for A, we have 3, 2, and 1. For B, we have 1, 3, -2 for our coefficients. For C, we have -1, -5, and 3, and then 0, 1, -4 for our right-hand side. Okay. Now, we have to remember that our goal, when we're using Gaussian elimination and back substitution, is we want ones down the principal diagonal and zeros below it. So, in other words, we want it to look like this. And as before, we want to, in each column, get the 1 and then the zeros, move to the next column, 1 and then the zeros, and so on, as many columns as we need. So our first goal is to put a 1 in the upper left corner. And there are two ways to do this, at least. One is to just multiply that first row by the reciprocal of 3, which would be 1/3. And that'll introduce fractions, which is usually inevitable. But in this case, we can postpone them for a step if we will, instead of doing that, if we will simply swap or switch row 1 and row 3. Row 3 has a very convenient 1 in the first position, so if we just trade those, now we have a 1 in the place that we want, and we didn't have to have any fractions, and we didn't have to do any work. Okay, so now once we've got the 1, now we want to get zeros here. So for the first one, we're going to need to do -2 multiplied by the row with the 1 in it, which will be row 1. Add the row you're working on, and then put it back in row 2. How are we going to get the 0 in the third row? Take the opposite of that number, which will be -3, times the row that you're working on. -3 times the row that has the 1 in it that we created. So that would be the first row. And then we're going to add the row that we're working on, and we're going to put it back into that same row. Okay, so if we do -2, once again, I'm going to put a little bit of scratch work down below. -2, row 1. So that'll be what? -2, +4, -6, +8. Now we're going to put our row 2, which is 2, 3, -5, 1, So 0, 7, negative 11, and 9, and that's going to go back into our row 2. So row 1 stays unchanged. Then we get 0, 7, negative 11, 9 for row 2, and now we need to do row 3. So here we're going to do negative 3 row 1. And so that's going to give me a negative 3, a positive 6, a negative 9, and a positive 12. We're going to add row 3. So we get 0, we get 7, negative 10, and 12. And that's what we're going to write up here into row 3. Okay, so now what is our goal? Now our goal is to get a 1. We finished the first column, so now we move to the second column. We want to get the 1 and then the zeros. So we want to get a 1 in the second row right here. Those are easy. We simply multiply by the reciprocal, 1/7 row 2 into row 2. This is what forces the fractions to turn up. So we get 0, 1, negative 11/7, and 9/7. Row 1 and 3 stay the same for now. Okay, now we need to get a 0 here. Okay, just getting rid of my scratch work so I can do new scratch work. So we want to take the opposite of that number, so negative 7, multiply it by the row with the 1 in it, which is row 2, and then add it to the row we're working with, which is row 3, and then that's where it goes. Okay, so my first row stays here. My second row stays here. And so now scratch work down below. If we do negative 7 row 2, what do we get? See how it's not going to undo the 0? So that's the nice thing. 0, negative 7 times negative 11/7 is going to give me positive 11. And then negative 7 times 9/7 gives me negative 9, right? And then we add row 3, which is 0, 7, negative 10, and 12. And so we get 0, 0, 1, 3, which is what's going to go back into this last row. And the next thing that we want is to get a 1 here, but we already have it, right? So that's kind of convenient. So we don't have to do any more row operations. We are already in row echelon form. And so now we need to do our back substitution. Okay, so back substitution means we're going to start with the last equation first, because that's the one that we don't have to do any work to solve. What variables do we have? We had A, B, and C, so don't forget what variables you're working with. So here we start with C equals 3, and that's from our third row. And then we go to our second row, which says that B minus 11/7 C is equal to 9/7. And so now we just put in our C equals 3. So B minus 11/7 times 3 is equal to 9/7. So my B is equal to 33/7 plus 9/7, which is 42/7, which is 6. Okay, and now we want to go back to row 1, which told us that A minus 2B plus 3C equals -4. And so then A minus 2 times 6 plus 3 times 3, that's putting in our B equals 6 and our C equals 3, is equal to -4, so A. And this should be a -3 right there. And so then my A is -1. And so my A, B, C order triple turns out to be -1, 6, 3. I hope that helped with the Gaussian elimination and back substitution. Good luck, and